Hello everyone, this is Team Nameless X and today we are going to represent our digital lab project. The project topic is State Elevator Control Machine and I would like to explain this in detail. Now I would like to talk about the team members of our project Nameless X. The team members are as follows. Me, Deblina Ghotuk, a student of Institute of Engineering and Management, Kolkata, and in the stream of Computer Science and Engineering second year. The other team members are Shourodi Patur, who is also a student of this institute and in the stream Computer Science and Engineering, and Shagnik Kaur, who is also a student from this institute and in the stream Computer Science and Engineering. Our project number is 2 and the project title is Designing a State Machine Elevator Control System. Now I would like forward to take over the project. Now I would like to start over with the experiment description of the entire project. As experiment description forms an integral part of the project, so it is better to know that how we have designed the state elevator control machine. So we have here designed a state machine elevator control system and it has the following characteristics. We have created an elevator which has generally 6 floors: ground floor, first floor, second floor, third floor, fourth floor, fifth floor, and in our elevator we have added an extra 6th floor. There are 2 buttons on each floor outside the elevator for requesting to go up or down from each floor, except ground floor has a single button requesting to go up and the 5th floor has only one for requesting to go down. There are 6 buttons, in our case it's 7, inside the elevator, one for each floor for choosing the desired or destination floor. The elevator remains inactive until a button is pressed. The door should open each time the elevator completes a request, either for letting a person in or out of the elevator, and should close exactly after 10 seconds. There are 2 indicators that show whether the elevator is moving upwards or downwards. The elevator will be simulated with the floor counter and an LED display which will show the current floor. So this is the diagram which also shows a depiction of an elevator. This is it for the experiment description. Now I am going to describe the components and the simulation platform that we have used in our project. First, I will tell you the simulation platform that we have used. The simulation platform used here is Tinkercad. The components are listed below as follows. 2 Arduino Unos, breadboards, jumper wire, 7 segment display for creating a 7-floor elevator, push buttons, LCD display, potentiometer, and finally resistors. Then I would like to continue with the next part of the project. Now I would like to start with the overview of the elevator control system. I would like to describe the overview in detail. The overview is as follows. The elevator controller system uses a finite state machine to take floor inputs from inside the elevator and up and down calls from outside the elevator to determine the movement of elevator from the current state to the desired next state. The low voltage power supply is for the controlling component and the fixtures are there to control the elevator. Our elevator control system, as mentioned earlier, comprises of 2 Arduino Unos. Each Uno has been assigned its proper task. One of the Unos acts as the main driver unit, the other Uno acts as the input or the control unit. The communication between the Unos is in serial pattern. Here is a diagram or diagrammatic representation of the elevator controller system. Now my friend Shagnik Kaur will go through the next part of the project and will describe you in detail.
Thank you, Devolina. Now we will move on to the working principle of this project. As you all can see, this is the main driver code, which will be explained by my friend Shododi Pathar later in this presentation. We have the controller code, which will also be explained by my friend Shododi Pathar later in this presentation. Now, moving on to the working input table of the state machine elevator system. But before going on to the details of the table, let us have a look at the circuit diagram of the elevator control system. As you all can see, there are 7 buttons, each representing a floor. The first button represents the ground floor and the last button represents the 6th floor. Now, coming to the table, as you all can see, as we are pressing the button B0 and the input becomes high, but the other inputs remain 0 and the resulting output becomes 0. Similarly, when we are pressing the button B1 in the next case, the input becomes high and the other input remains 0 and the output becomes 1. In a similar way, as we are pressing the button B2, B3, B4, B5, B6 respectively, the inputs become high and the other input remains 0. And in a similar way, the output becomes 2, 3, 4, 5, 6 respectively. Now, as you all can see, this is the circuit schematic of the main driver unit. Now, as you all can see, this is the circuit schematic of the main controller unit. Advantages of the state machine elevator control system: to bring the lift to the correct floor, to minimize the travel time, to maximize passenger comfort by providing a smooth ride, to accelerate, deaccelerate and travel within safe speed limits. Applications of this elevator: elevators or lift as they are commonly called is a form of vertical transport used primarily to move between multiple floors found in high rises and skyscrapers. They are used to transport both people and goods from one floor to another. Elevators are seen in large ships with multiple decks. Future prospect: we will add a motor drive unit, we will add various sensors, we will add other peripherals necessary for a complete elevator in the future. Now I would like to hand over the presentation to my friend Devolina, who will conclude the presentation.
Thank you, Shagnik, for explaining the project in detail. Finally, we have come to the last and concluding part of the project. This is it for our entire project. Hope you all like it. Now my friend Shorudi Patul will explain the working principle, the main driver code, the circuit and the schematic diagrams of the project. So let's move forward.
Thank you, Devolina. So, as she mentioned, I will be explaining you the circuit diagram, the overall circuit, and the code for the elevator control system. So, let's start with the simulation. As you can see, the elevator is activated. So, here are the 7 buttons. As mentioned earlier, the first button represents the ground floor. This is the button for the first floor, this is for the second floor, and consecutively at the last, this is for the sixth floor. Now let's press a button. As you can see, this is the button for the third floor. I'm pressing this button. As you can see, the status of the elevator gets updated and it is currently going up, and it should stop at floor 3. We are currently at floor 2, and as you can see, we have reached floor 3. And as you can see, the 7 segment LED display also shows the value 3. Now let's move on to another floor. Let's say, for example, floor 5. I'll press this, and the status is again updated, and we are going to floor 5, and hence we reached floor 5. Now let's say we want to come back to floor 1. Let's press the button for floor 1. As you can see, it is going down. We are currently on floor 3, and it is still going down as our aim is to reach floor 1. And you can see we have reached floor 1. Starting off with the code, we have included the library for the liquid crystal display. And as you can see, here are some values, here are some variables on the unsigned constant int a b c d e f g h. As you know, seven segment displays have each terminals, and they are marked A, B, C, D, E, F, G, and H. The pin number A of the display is connected to pin number 13 of the Arduino Uno, B to the 12, C to the 11, D to the 10, E to 9, F to H, G to F to 8, G to 15, and H to 14. Here is the variable floor coefficient, which is set to 1. We will see this later in the code. The variable digit stores the digit that is shown in the displays, and the state variable is used to take input from the serial monitor. The liquid crystal display is hooked to the pin number 7, 6, 5, 4, 3, and 2. There are two functions: print digit, which prints the value for the 7 segment display, and update status, which updates the value for the which updates the value for the string element status, which is going up and going down. As you can see, these are the main functions for each value that is printed in the 7 segment display: void 0, void 1, and we have all the way till 9. Starting with the main code, which is the void loop. Void loop runs as the infinite loop, and it will go on unless and until we put a break to the code. As you can see here, it is written serial.available, which is greater than 0. This is the command which checks if there is a serial input in the serial monitor, and the state variable, as mentioned earlier, stores the value that is taken from the serial, and we are using a switch case to assign value to the variable x, which we will use as the main variable for the driver code. As you can see, the default variable, which is -1, and it will not switch to this block unless and until the value is greater than -1. So if we receive input from the serial, we should the x should have a value which is greater than -1. This is the main code. This is the main block, which is the main working principle behind the elevator control system. The elevator oscillates between each floor. As you can see here, the floor if the elevator reaches its limits, the floor coefficient is inverse and the status is updated. If the flooring is going upwards and the floor has reached floor number 6, the status would be updated to going down. And similarly, if the floor is going down and it has reached floor number 0, it will be changed to going up. For this part, this block of the code, make sure if the digit inputted in the serial and which is stored in variable x, if the it is encountered, the loop simply breaks, and we it shows the status reached floor. That's all about the code for the first Arduino Uno. Let's move on to the second Arduino Uno. This is the code for the controller unit, where we take input from the buttons. As you can see, here are 7 buttons, which has consecutive bits, and here each bits represents their each switch. As you can see, we are reading the state of the button from the by using the function digital read. As you can see, if the button is pressed, the button state will simply be turned high. the button state 0, which is for this button. If it is high, then we simply it simply transfers data in serial to the first Arduino Uno, which is the data is 0. And similarly, for each floor, if each button is pressed, each consecutive data is sent. Thank you, everyone. That was a brief explanation about the working code and the circuit diagram of the elevator control system that we have designed. Thank you very much, and I would like to show our regards to our professors, Professor Monalisa De, Professor Arpan Chakraborty, and Professor Sona Das. Thank you very much.